Okay, so for today's lecture, I would like to continue our discussion on the collections framework and generics. Today, we're going to talk about a different type of data structure. So up to now, we talked about list and we've talked about sets, and we've distinguished between those two, but there's another core data structure we really have to evaluate, and that's going to be maps. So let's do a quick overview. Well, we'll do an introduction, and then we will talk about the map interface and the hierarchy for the map interface. And then we'll look at the map implementation classes, or the classes, the concrete classes that implement a map. We'll talk a little bit about the Map.Entry Interface and why that's pretty critical to us. We'll talk about the constructors, the methods, and then do some source code. So a map in Java is a container object that stores elements in the form of a key value pair. So a key has to be unique. That's a unique element. It can be any object that serves as an index in the map. So maps, you can think of, so think about an array, for instance. With arrays, we have a set of values that could be any type of object in Java, but the way you access those objects is with an index number. A map is similar, except that instead of using an index number, we could use any Java object. So the element is associated with a key, and then the key is bound to a value. And so that's why it's called typically a key value pair. So a map stores the values associated with the keys. In a map, both keys and values must be objects, and they cannot be primitive types, just like all the other collections. So if you do want to use a primitive data type, you have to use the reference type data type. So you got to use integer with capital I, for instance, or double with a capital D. A map cannot have duplicate keys. So just like a set has to have unique elements, a map has to have unique keys, because again, that's how we're using it to index in to get back a value. Just like a array, for instance, can't have duplicate index values, but each key maps to only one value. This type of mapping is called a one-to-one mapping in Java. Okay, so all keys must be unique, but values may be duplicated. The same value can be stored to several different keys. A key and its associated value are called an entry. So that key value pair together, that is an entry. Those entries are what's stored in the map, as shown in this figure here. After the entry, which is the key value pair, is stored in a map, we can retrieve or get its value by using the key. The figure shows a map in which the entry consists of ID numbers as our keys here on the left-hand side, and then a name, which is modeled as a string, as the values. And notice we can have duplicated values, but it's important that all of our keys are unique. So the map interface. So map interface in Java is defined inside the java.util.map package. It is part of the Java collections framework, but it does not extend the collection interface. So the Java map interface is defined like this: public interface map, and then inside of the generic type, notice it's a key value, KV, and here the K represents the key and the V represents the value. And those would be the data type for your key and value. So for example, a mapping of integer keys, and again, reference type of integer, we're going to use, the string values can be represented with a map that is an integer string key value. The map interface provides the methods for fast retrieval, deletion, and updating of the pairs through the key. So to look at a hierarchy diagram of our Java map interface is right here. So here you can see we have our map interface. And so we have a class that implements the map interface. We also have a sorted map interface that can extend map. We have a hash map, which is concrete class that extends the abstract map. We have a tree map that extends the abstract map. The tree map also implements the navigable map, which extends the sorted map, which extends the map interface. And so we'll look at all of this over the course of these lectures. But you can see here that the map interface serves as the root of all the concrete maps. So sorted map interface, a sorted map is a sub-interface of map, and it extends the map interface. The entries in the map are maintained in ascending order based on the keys, and that's true for a sorted map, not necessarily for any other type of map. Hence the name sorted map. Sorted map is generic and it's declared like this. It's an interface sorted map of key value data types, where K is your key and V is your value. And some of the interesting methods that are defined by the sorted map interface, that anything that implements the sorted map interface would be responsible for implementing, would be a comparator, an entry set, a first key, a head map, a key set, a last key, and some more. These are some highlighted ones, and we'll try to look at some source code versions of that too. The navigable map interface is a recent addition to the collections framework, and it was added in Java 6. It extends the sorted map interface. Tree map and concurrent skip list map classes are concrete classes that implement the navigable map interface. As the name suggests, navigable map provides many useful methods that make the map navigation easy. So we can retrieve entries based on the closest match to a given key, and the navigable map is a generic interface that can be declared like this. So again, interface, navigable map, and then for the generics, it's going to be your key, comma, your value. So the methods defined by navigable map interface are the ceiling entry, the ceiling key, descending key set, descending map, first entry, and last entry. And again, we'll take an examination of these methods that this interface goes ahead and requires implementation for later on when we start looking at some examples. Now, in terms of the map implementation classes, the collection class library has several different classes that provide implementations in the map interface. And so actually, the map interface has, I want to say 7 different concrete classes. We're not going to examine in depth all of these. I might give you slide decks on all of these, but for our lecture hours, we're only going to hone in and probably look at 3 of these. So we'll just quickly mention them here so that you understand what are the 7 concrete classes that the map, that implement map, and then we'll look at some of these in greater detail. But I'll try to give you slides for all of them so you can read about them if we don't cover them all in lecture. So we have an abstract map. That is, of course, our abstract class that implements the map interface. It is the parent class of all concrete map implementation classes, such as hash map, tree map, and linked hash map. It implements all methods in the map interface except for entry set. We have an enum map. The enum map class extends the abstract map and implements the map interface. It is especially useful with keys of enum type. We have a hash map. It is a concrete class that extends the abstract map. It uses a hash table to store elements. It is mainly used for locating a value, inserting and deleting an entry. We have a tree map. It's also a concrete class that extends the abstract class and implements the navigable map interface. It used a tree for sorting the elements. So it's used for traversing keys in sorted order, and the keys can be sorted using comparable interface or comparator interface. We have a linked hash map. It's a concrete class that provides implementation of the Java map interface. It extends hash map along with a linked list implementation that supports the insertion order of entries in the map, because by default, maps are like sets where they're not ordered. So the entries in a hash map are not ordered, but entries in a linked hash map can be retrieved in the order in which they were inserted into the map. We have a weak hash map. The weak hash map class extends abstract map interface to use a hash table with keys of weak type. So up to this point, we've only ever seen references that are strong type, but weak keys allow an element in the map to be garbage collected when its key is no longer used anywhere in the program. And then there's an identity hash map. This class extends abstract map and uses reference equality for comparing entries. This class is not used for general purposes. So those are the 7 concrete classes. We'll probably look at linked hash map, tree map, and the hash map, because those are comparable to the set implementations that we covered previously. Let's talk a little bit about the Map.Entry interface. So the Map.Entry interface enables us to work on an entry in the map. An entry of a map is an object of type Map.Entry. So entry is it's a subtype of map itself. So it's a subclass within map, which is why we have one class nested in the other, separated by a dot operator. Where entry is, an inner interface of the map interface. So here, Map.Entry interface is defined in java.util.map.entry package. Each Map.Entry object contains one key value pair, and the Map.Entry is a generic interface, and it's declared like this, where, of course, you would replace the K and the V with whatever the data type that is the key and the value. So there are several methods defined in the Map.Entry interface. So some of the ones that are worth just discussing so that you're aware that they exist. They have an equals method that checks for equality. Returns true if the specified object is a map entry whose key and value are equal to the existing object. We can get a key, so it's used to retrieve the key for a map entry. We can get a value, so that's used to get the value for a map entry. We have a hash code that returns the hash code value for a map entry, which is effectively an integer value that uniquely distinguishes that object. So we could use it kind of like an ID number. And then we have set value, where we can pass in a value and we replace an existing value with a corresponding in our entry with a new value. So how do we create a map object in Java? Well, we can create an object of a map using its 3 concrete classes, either hash map, linked hash map, or tree map. Here, let's take an examination of the hash map constructor, just to get a sense of the general syntax. So here, we're going to declare our variable of data type map. And inside of the angled brackets, we have to declare a type for whatever the key is and a type for whatever the value is. Then we can give it a label here or an identifier. Here, we'll just call this map. And then we will assign it an instance based off of invoking its constructor. So new keyword, then hash map. And then there's a number of different kinds of constructors we have. We have the empty constructor, which makes an empty map. Or we can create a map by initializing elements off of some other map here, where we pass a map reference in. Or we can create a map with an integer value that gives it an initial capacity for our hash map. Now it organically grows. It's not like an array, so you're not limited towards the size. Also, you can create a map object with the initialization and what the fill ratio is. Okay, some basic methods that are worth mentioning for map. We have a put method that takes a key value pair, and it's used to add an entry with a specified key value in the map, and then that will return back the value. We have put all, where we can pass in a map object, and that's used to add all entries from one map into the current map. We have put if absent, where we can provide a key and a value, and that's used to add specified value with specified key in the map only if it's not already specified. So if it's already there, then it won't overwrite the value. We have a remove method where we can pass in a key, and it will go ahead and delete that entry, and it will return null if the key is not in the map, and it'll return the value if it was. We have a remove method where we can pass in a key value, key as the first parameter, value as the second, and it will remove that from the map and then return back a Boolean value, whether it was successful or not. We have key set. This method returns a set consisting of all the keys inside of the map. We have clear, which will clear all entries of the map. We have a get, where we can pass in a key and it will return back the value at that key. We have hash code that returns an integer, and that just returns the hash code for our entire map object. We have is empty, where we can query our map to ask whether it has entries or not. We have size, that will return the number of entries in our map. And then we have replace, where we can pass in a key as the first parameter, a value as the second, and this will replace the specified value for that key and then return back that value. We have replace, again, where we can put in a key, and then we pass in the old value and we pass in the new value. And this method is used to replace the old value with the new value for a specified key. And then we'll return true or false, whether that was successful or not. We have the ability to get back the collection of values inside of our map. We can put in a key to the map and do contains key, and that returns true or false, whether that key exists in the map or not. We can do the same thing for a value. We can pass in, we can invoke contains value, pass in a value, and get back a Boolean value, whether that value is in our map or not. And then we also have an equals method, which will compare that object that's passing the parameter to our map and determine whether it's the same set of entries. And if it is, it's true. Otherwise, it's not equal. Okay, excellent. Let's take some example programs where we will perform some useful operations like adding, removing, and replacing an entry in a map based off of the above methods that we just discussed. So the first example software or program here is, let's try to add entries in the map using the put method. We'll also check a map if it's empty or not before adding entries in the map. So let's take a look at our source code, and this is going to be our map tester one. So let me jump over here into IDE. Come on, computer. Okay, let's close all this. Close, 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 close. Oh my. Okay, so let's go to map tester one. Okay, so inside of here, I'm going to import the concrete class hash map so I can actually instantiate a map. I'm going to import my map interface. I'm going to create a class map tester one. I'm going to create a main method so I can actually create an application that's going to execute. Here, oops, stop that. Here, I'm going to go ahead and create a variable with the name map and data type map using the interface. Inside of the angled brackets, I need to do a key value pair. Here, my keys are going to be integers and my values are going to be strings. I'm going to create a new hash map. So I'm going to invoke the constructor of my concrete class. Then on my map, on my empty map, I'm going to invoke that method is empty. I'm going to save that into a Boolean variable and I'm going to print that out. Then I'm going to put key value pairs in there. So the put method requires me to have as the first parameter a key and the second parameter a value. And so here, my keys are going to be strings. They have to be unique. So I'll do 101, 103, 102, 104, 106. And then I'll do my values here, red, green, yellow, blue, and pink. Then I'm going to go ahead and print out the state of my map. Then I'm going to query my map for its size, how many entries are in there, and then I'm going to print that out. Then I'm going to create a new hash map that uses the same key value pair. I'm going to put some new entries into that. So some keys and some values. And then I'm going to put all the entries from map 2 into my original map. And then I'm going to print out the new state of my map. So we can see a variety of ways of adding elements, entries into my map. So let's go up here and actually just run this. And so here is map empty? Yes, it's true. And then we're going to add elements, and then we're going to print the state of our map. And you can see in the state of our map, we have our key value pair. So 101 is red, 102 is yellow, 103 is green, 104 is blue, 106 is pink. Then the number of entries in the map after our puts is going to be 5. And then the entries after we do the put all is going to be all of these here. Excellent. Okay, the next thing I want to look at with just using the basic methods that we've learned about maps is removing entries. Let's create a program where we remove entries from a map using the remove method. So again, let me hop on over to the IDE so we can actually run this code. So here I'm going to also go ahead and just import the concrete class hash map so I can actually instantiate an instance. And I'm going to also import my map interface because that's what we're really focusing on right now. I'm going to create a class map tester 2 that allows me to just create a main method so I can actually implement and execute my code. Here I'm going to create another map variable where inside the angle brackets, I'm going to use the key value pair where the keys are going to be integer data types and the values are going to be string data types. And I'm just going to instantiate an empty hash map. I'm going to put some keys values in there. So I have my keys, I have my values. Then I'm going to do the remove method where I pass in the key. And I'm going to print out the state of my map after I've removed key 104. So that should remove blue from our map. Then I'm going to remove the entry 106 in pink and go ahead and display that. So here, this will remove an entry for the specified key. Here, this will remove a specified value associated with the specified key for the map. And then finally, I'm going to clear my map. So if I run this, we can see here, I had removed 104. So I have red, yellow, green, and pink, but 104 is no longer a key in there. I no longer have the value associated with that key. When I remove the key, I remove the value. I can also remove based off the key value pair. So here you can see I have also removed pink, or 106. And then finally, clear just removes everything. Okay, the next thing I want to do in terms of playing around with the map type will be to create a program where we can replace a specified value for a specified key. So let's take a look at that source code. Let's go to Map Tester 3. Here we go. So here I'm going to go ahead and import a different concrete class. Wait, no, that's not right. Map Tester 3. Okay, here we're going to go ahead and import map, our map interface. Here we're going to import our hash map, our concrete class. Here I'm going to go ahead and create a new class. So I can create a main method. Inside my main method, I'm going to create a data type map. This time I'm going to vary it up. I'm going to have my key as a string data type, and I'm going to have a value as a string data type here. So you could see how flexible maps are for allowing us to index with unique and novel things. And here I'll create a new hash map. I'll put some key value pairs in here. So I'll have my keys be A, B, C, D, E. And for A will be apple, and B will be boy, and C will be cat, and D will be dog, and E will be elephant. Then I'm just going to go ahead and print out my map. Then what I'm going to do is I'm going to say, hey, map, replace the specified value for this key. So for E, for elephant, replace it with an element. And then we'll print out the new state of our map. And then we're going to do a similar thing here. We're going to say, hey, map, replace at the key B, the old value with boy with bucket. And we'll print that out as well. So here you can see our original entries was A for apple, B for boy, C for cat, D for dog, E for elephant. Our updated entry is now E for element. And then here you see, after we also do the replace with the 3 parameters, it's B for bucket. So this replacement did change out bucket. This one changed out elephant for element. Okay, the next thing I would like to see using our map data type would be to be able to get keys and values. So let's make a sample program where we can get the set view of keys and get all the values from our map. So here, let me go to my map tester, 4th example. So here I'm going to import the collection interface. I'm going to import the hash map, the concrete class hash map, so I can instantiate it. I'm going to import my interface of map. I'm going to import my interface of set. I'm going to create a new class so I can have a main method. I'm going to create a map here that is that uses the string of the key value pair of string and string. And I'm just going to make an empty hash map. I'm going to put some key value pairs in there. So BB, DH, AA, CR, ET. Then what I'm going to do is I'm going to, from map, invoke its key set method, which returns a set of the keys. So since the key is data type string, I'm going to create a set of strings, and I'm going to call that my keys, and I'm going to store that in there and print that out. So that should be just the keys inside of my map. And then the values that get returned from map.values from that method call is going to be a collection, because it can have duplicates. So remember, a set is always unique. And so our keys always have to be unique. So that's returning a set, whereas a collection could potentially have duplicates. So for our values, since those could have duplicates, we'll get those back as a collection data type. And since the value is data type string, we will go ahead and use string to hold our collection of values. And so that we'll print those out. So let's go ahead and run that. And here we can see our set of keys is A, B, C, D, E. Yep, that's our set of keys. And as you can see, we're not necessarily we have an alphabetical ordering here, but it's not guaranteed any ordering for this. And then for our collection of views here, of values here, we have our A, B, R, H, T, which is all the values that are inside of our map. So we do have the ability to see the keys and just the values. Now let's talk about just getting a value for a key. Let's create a sample program where we get a value for the specified key in the map. We'll also check whether the map contains an entry for the specified key. So let's jump over here. Let's open up our map tester 5. And so here I'm going to go ahead and import my hash map, my concrete class. I'm going to import my interface map. I'm going to create a new class with the main method. I'm going to create a map variable where the key is a string and the value is a string. I'm going to create a new empty hash map. I'm going to add some or put some values into it. So here I'm going to have V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. Then I'm going to query my map. Hey, map, get me the value that corresponds with the key of V. And I'm going to save that as a string because that's the data type our values are. And then I'm going to print that value out. And then I'm going to ask, hey, map, do you contain the key B? It's going to return either true or false. I'm going to print out the response of that. Then I'm going to query the map. Hey, do you contain the value of brown? Don't see a brown in there, but that's going to return back a true or false value. And then we're going to print out the result of that. So here, when we run this, we can see that if we get V, if we query with the ID of V, we're going to get back as the value of that key, violet. If we ask the map if it contains the key B, well, that's true. If we ask the map if it contains the value brown, well, that's false. And that's just a quick kind of overview over what maps are as a data type and what we can do with them in Java. Now,